Let's get started. It says to graph these on the same grid. That instruction applies to every single one of these. We're graphing at least 2 equations, every single one of these. So for the first one, we're going to graph the equation 2x minus 3y equals 12 and x minus 4y equals 4 on this graph grid. And when we get finished with that, I want to make sure that we've labeled and scaled the x-axis and the y-axis, and that you label the line with the equation. That's going to be also very important in Chapter 3. And that you label the x-intercepts, the y-intercepts, as long as there are. Sometimes there will be some lines that won't have both. And then we're going to label the intersection point of the lines if they cross. Okay? So I'm going to move the instructions out of the way so I can just see the graph grid. So the first thing we probably want to do is we want to find the x and the y intercepts, and I'm going to show you how to use your calculator to find those. You should use your calculator to help you with this. So I'm going to get the calculator. Turn it on. We're going to go to y equals. And I'm going to show you a way that you could put these in the calculator and not make algebra mistakes that will cause you not to have the answers that you want to have. Okay? Since we want to solve 2x minus 3y equals 12 for y in order to be able to put it into the calculator, when I put this into the calculator, I'm going to put it in as y equals, and this is going to be at y1, and I want basically this 2x to go over here with 12. So I'm going to subtract it from both sides. So that's going to be now negative 3y equals 12 minus 2x. Okay?
Negative 3y.
Right. So what I've done is I've just moved this from here over to here. And now I need to divide everything by negative 3. In order to be sure I do that and don't forget about sign changes and all that kind of stuff, put parentheses around what's on the other side and then put your division sign and your negative 3. And that divided by negative 3 will also get rid of the negative 3 in front of the y. So we'll have y equals parentheses 12 minus 2x, close parentheses, divided by negative 3. And that's what we're going to put in the calculator. So we'll do that one first. Okay? I know that doesn't look like y equals mx plus b. If we simplified it, it would. But we're not going to simplify it because we're not worried about algebra right now. We're worried about being able to graph this and being sure that it's right. Okay? So before I go any further, I'm going to hit my zoom button and go down and select option 6, which is your standard window. Zoom 6 takes you to an x-axis that goes from negative 10 to positive 10 and a y-axis that goes from negative 10 to positive 10. And there I see a graph of that equation. Now I've got to figure out how I can transfer that graph onto here. So what I want to do is I want to know what the x and y intercepts are. So the first thing we're going to do is we're going to find the y-intercept by hitting the second button and then the trace button. And if you look at the top, this is a calculation menu that goes with your graph. It will calculate points for you that are on your graph. The first thing it says is value. Value says, if you tell me what an X value is, I'll show you where that is on the graph. That's what value does. If you tell me an X value, I'll show you where that X value is on the graph.
X-intercept?
No, it's actually going to be your Y-intercept.
One is your,
One is going to give you your Y-intercept, okay?
yeah, we did it in algebra, and I forget. Zero shows you your X.
Zero shows you your X-intercept.
Yeah.
So we're going
Minimum and max show you your vertex if it's minimum and max.
Right. So we're going to use value, and I want to know where the Y-intercept is. The Y-intercept, let me pull this off to the side and write this down for you. Your Y-intercept is where X equals 0. Your Y-intercepts always look like 0, comma, some kind of a Y value. So if we let X be 0, it'll show us what the Y-intercept is. So you just type a 0 and hit enter. So it says the Y-intercept is 0, -4.
You hit value and then hit zero.
Yes.
And hit enter. And Y is -4.
So when you want your Y-intercept, you want to go to the calculate menu and choose one value and let X be 0. And it'll tell you your Y-intercept. Then the next thing that we want is we want the X-intercept. That's where Y is equal to 0. But unfortunately, the calculator is not going to let us ask it for a value for Y and it tells us X. It doesn't work that way. So the thing you need to know is that on the calculate menu, the way we do this is the second option. It's called zeros.
Don't you have to move your point down by the line or move it to one side?
You
of
do.
it?
You do. So we're going to go back second trace to calculate. And this time, I'm going to ask it to find the 0 for me. I'm going to move this calculator onto the side so we can see what I'm doing on both things. So I'm going to go down and, excuse me, and choose 0 and press enter. Now, you need to know where the X-intercept is, and you can see it. You have to be able to see it. If you can't see it on your window, you're going to have to adjust your window. But the ones I've given you here, you can see all of them. So what we're going to do is we're going to move the cursor that's flashing right now on 0, -4. We're going to move it up close to where we think the X-intercept is. Now, it doesn't matter if you go to exactly the same point that I do. The key is that the X-intercept occurs when the line is below the line, the graphed line is below the X-axis and above the X-axis. So the first thing you have to do is choose for it to be below the axis, or the left bound in this case. That's what it's asking. Move to the left of the X-intercept. Okay? So get it close. It doesn't have to be the same exact number I have, but get it close and hit enter. And notice it puts a little, kind of like a golf flag up there at the top. It hops up there at the top of the screen and it puts a little triangle, a little arrow that's pointing to the right. And now it's changed its question. It says right bound. What it's telling you is, where do you want me to stop looking? Where it put my cursor to the right of the X-intercept. So I keep moving the cursor And what you'll see happen is your y value goes from being negative to being positive, right about there. But I'm going to move a little bit further over so I can see that I'm definitely past that that x-intercept. And then I hit enter again. Now, as long as what you see at the top of that screen is two triangles pointing towards each other, not away from each other, but towards each other, then it's going to find your intercept for you. So now that those are pointing toward each other, the calculator asks me if I want it to guess, and it's a really good guesser. So I hit enter to tell it, yes, guess for me. And it says the the x-intercept is 6, 0. Okay? Now that pretty much tells me everything I need to know to be able to graph this equation then. I've got all the information I need. I know that I need to have a window that shows me the points that are my x and y intercept. And this is between negative 10 and 10, and this is between negative 10 and 10 for the y value. So I'm going to get a ruler, and I'm going to try to put this in just about the center of the graph grid. Draw a big heavy line. And this is my y-axis. So I'll label it y. And then I go across and do the same thing to make my x-axis. That's my horizontal axis. And then I'm going to plot those 2 points. So the first one I plot is 0, then down 1, 2, 3, 4. So that's 0, negative 4. And then I'm going to go start at the origin, 0, and go right 6. 1, 2, 3, 4, 5, 6. And that's 0.60. And then I'm going to connect up those points with a line. And I'm going to make it nice and straight. That's why we have a ruler.
You want arrows on the end of the line?
And we want arrows on the end of the line. Because that line actually continues on in this direction forever, and it continues on in that direction forever. And then the last thing I want to do is I want to go back to the original equation, 2x minus 3y, and I want to label it on that line. So that's 2x minus 3y equals 12. This is an acceptable graph when you do one on a test or when you do one to turn into me. You have to have all that information. Now we'll go to the other one. And the second equation, we have x minus 4y equals 4. So I want to move the x over here. And then I want to put parentheses around everything that's over there because I'm going to divide it by negative 4. through the same process again. Get the calculator. This time I'm going to go to the y equals, and I'm going to put this in y2. So I put my parentheses, 4 subtract x, close the parentheses, divided by -4, and just hit graph again. So now I know that I need to find a new y-intercept for this line. So I hit second trace. I choose value to find the y-intercept. I tell it where is x equal to 0. And the first one it shows me is the one I already know about, but if I use my down arrow key, it hops to the other one. And it says the y-intercept for that one is -1. So it's at 0, -1.
That 0, -4, that was like the last one.
That was the last one. Hit your down arrow key.
I had it put the equation, y equals.
But there's 2.
Okay, yeah. The graph was set to line. Okay, graph. And there's my 2 lines. Okay, now I'm going to
Second calculate, go to 0.
second trace.
Second trace.
Value,
Okay.
0.
X equals 0. Hit enter. Now press your down arrow key
Oh.
because you're moving down the list.
I see.
Okay?
It's doing the first equation first.
Right.
When you graph it, it starts back from the beginning.
Yes, it does.
Okay.
Okay, so now we need to find the x-intercept. And again, second trace. The x-intercept is called a 0. So we choose enter. And notice it always goes back to the first equation in that list, so you're going to have to move it to the line that you're wanting to work with. So you can hit your arrow key and move, make sure you're on the line that you're wanting to look at. So I need the x-intercept. I'm going to trace just a little bit closer and hit enter. And then I'm going to trace on past where it actually goes above the axis. My y values are positive now, so I'm going to hit enter again. And the 2 little triangles are pointing towards each other. As long as they point towards each other, I'm going to be able to find it. So I say, go ahead and guess. And it says, okay, that point is 4, 0. So now I'm ready to draw that line. So again, I'll lay down the ruler. I'll draw a nice straight line. And my marker's better than 4 o'clock, so try a new one. So now this line with the calculator. This line is x minus 4y is equal to 4. And I have one thing left to do. Because I have labeled and scaled the x-axis and the y-axis. I've labeled them. And to scale it, all I really need you to do is put some of the points in there. So when I scale those axes, what I do is I say -1, -2, -3, -4, -5. And I only mark -5. I don't have to have all those numbers on there. That gets cluttered after a while. And then here, 1, 2, 3, 4, 5. So that's +5. And then 1, 2, 3, 4, 5. -5. 1, 2, 3, 4, 5. +5. So that's scaling the axis. And then I've labeled my lines with the equations. I've labeled the x-intercepts, I've labeled the y-intercepts. I only have one thing left to do.
Where they cross.
I need to know where the intersection point is. Now the calculator's going to help me with that too. The only thing is, if the calculator is going to be able to help you find the intersection point, your calculator has to be able to see the intersection point. It has to be on screen. So if your lines haven't crossed, you're going to have to adjust your window so that you can actually see where they cross. Now, fortunately for us, we can actually see where these lines cross. So all we have to do is hit Second, Trace, go back again to that Calc menu. And we're going to choose number 5, intersection point.
Get it in there twice.
All you have to do, that's right, you go down and you either put your cursor in front of 5 or you tap the number 5. And then once you get back to your graph screen, you hit enter 3 times. 3 enters. You don't have to move the cursor or anything. As long as there's only one intersection point. If there's more than one, we would have to. Right now, we're only going to have one. And it says the intersection point is 7.2 and 0.8. So we've now labeled the intersection point. Now, even though the calculator finds it for you, just as a reminder, I could also have used matrices. I could have taken my original 2 equations, 2x minus 3y equals 12, and x minus 4y equals 4. And I could have turned that into a matrix and do reduced row echelon form on that matrix.
Is it right out?
And it shows you the exact same thing.
You want the matrix under like that?
You don't have to have it, I'm just reminding you.
Can we use it?
You can use it. Instead of doing, if you really would rather do the matrix rather than do the intersection point using your calculator, you can do the matrix. Because they are the same thing. It's showing you the same answer. It's showing you the one single XY pair that these 2 lines have in common, which is their intersection point. Okay? Let's try another one. And I'm not going to do all of these for you. And I see a typo, so I want you to go ahead and correct my typo. This should be equals to, not equal to or less than.
Calculator's in the way there.
I did the inequality version.
That should be an equals to.
So don't shade under it.
Don't shade. That comes in chapter 3. Now this one, we have y equals negative 2x plus 8, and it's already in a good form for the calculator, so all we have to do is type it in. So we can put that one in y1. Then we have two x equals equations. Your calculator does not graph x equals. It only graphs y equals. What does a line that has the equation x equals 1 look like?
It's got a 0 or wider.
Yeah, it's a vertical line. And it goes through 1, 0, because that's its x-intercept. Okay? And x equals negative 2 is also a vertical line. And it goes through negative 2, 0. So I don't need the calculator to help me with those two. So what I'm going to do before I even start with the calculator is I'm going to set it aside for a minute, and I'm going to draw my axes.
That's how we graph the line.
You see. Okay, the reason it's not, see that? Move your up arrow key onto that and hit enter, turn it off. That's what will stop it. And then just hit zoom 6.
Thank you.
You're welcome. If anybody has any trouble with your calculator, I'll be glad to help you. Okay, so now we have this nice big graph grid. Now I'm going to draw a horizontal line kind of through the middle of it. And that's my x-axis. I'm going to draw another one that's vertical. And the line I'm drawing right now, you need to understand, these two lines actually have equations. The equation of your y-axis is x equals 0. Just like the equation of your x-axis is y equals 0. They do have equations. So then I need to graph these two vertical lines, x equals 1. I know that goes to the point 0, 1. I'm sorry, 1, 0. I said that backwards. My bad. It's 1, 0. So I'll draw the line straight up and down. And this line is x equals 1. And then I'm going to draw the other one. X equals negative 2. So there's the point, negative 2, 0. The equation of this line is x equals negative 2. So those two were pretty easy. Now we need to graph y equals negative 2x plus 8. So I'm going to hit zoom 6.
What are we graphing
We're graphing this one,
the?
the very first one.
So you just put it in there and hit graph.
Right. And when you hit your second and your trace button, again, we need to find where x is equal to 0 to find the y-intercept. And it says that's 0, 8. So here's 1, 2, 3, 4, 5, 6, 7, oops, 8. I didn't plan very well. Sometimes that happens.
What can we do, just, can we mark the lines by 2s?
We could, but I've already graphed these, so
Yeah,
but that is a good idea. Colin has a good idea. He says, you know, if you don't want to put it all the way up here, there's nothing in the world says that you have to scale that by 1s. This is already scaled by 1s and everything fit. But this could be scaled by 2s. So this would be 2, 4, 6, 8, and there's your point 8, 0.
not that those, I already got those numbers. If we were on a test, we could do that.
Yes. I'm sorry, and this is not 8, 0, it's 0, 8. So there's nothing that says you have to scale by 1s all the time. If you need to, you can scale a graph by 2s, or by 25s, or 5s, or 50s. It just depends on what the graph is. So 0, 8 is my y-intercept. Now I need to find my x-intercept. Second trace. Go down and choose the second option, 0. Now this time when I get to the left of it, I'm still above the x-axis. When I move to the right of it, I'll be below the x-axis, so my y has to change signs. And since the triangles are pointing toward each other, it's going to find it, and it says that's at 4, 0. So 1, 2, 3, I'm sorry, 0, 1, 2, 3, 4. So then that line is the graph of the line y equals negative 2x plus 8. Okay? Now, since we can't draw those vertical lines on the calculator, well, actually we can, but it's more trouble than it's worth. Since we can't actually put these two vertical lines on the calculator and find intersection points, what we're going to do is we're going to take something that we know. This point is the point on y equals negative 2x plus 8, where x has the value of 1. So that tells us that that point then is 1 for the x value and 6 for the y value. And that looks right because, remember, we're scaling this by 2, so that would be, this is 1, and then up 2, 4, 6. And then we can do the same thing with the other intersection point. We know that that's where x is equal to negative 2. So y is 10, and that means this point then is negative 2, 10. So we've labeled our intersection points as well. But you do have to do a little arithmetic when you're dealing with vertical lines. Okay?
That'd be
What?
12.
Oh, yes, thank you. Thank you, thank you, thank you. Since Lexi was the one that I saw first, that was looking at me intently, then Lexi gets the bonus point. Remember, I promised you if you catch me in a math mistake, you get a bonus point. It's okay. Now, notice here again, it says all may not have both intercepts. These only have x-intercepts. They don't have y-intercepts. Okay? Label the ones you can find. And we've labeled all our intersection points. We've labeled our equations, so this is a good graph. Now, I'm not going to do every single one of these with you. I'm going to skip somehow I've got two of the same one. I don't know if you got two of the same one or not. Mine are printed bigger than yours.
It's the same.
Okay, well just, you don't have to do that twice. I must have accidentally duplicated ones.
You gave us credit if we did.
Well, yeah.
Sweet.
You don't have to do it twice. I'll give you credit for it both times if you do it once. How about that? Okay, now I'm skipping to the last one. The reason I'm skipping to the last one is because this is going to happen to us a lot in application problems. A lot of times, we only are being restricted to the first quadrant. Because we want x is 0 and y is 0. We only want them to be positive numbers. So basically when you see x is 0 and y is 0, you know that your graph really needs to only see or show quadrant 1. And quadrant 1 is where x is positive and y is positive. Okay? So rather than mess with a lot of lines that I'm not going to need, when I see that, I'm just going to go ahead and draw my x-axis on the edge of the graph. And my y-axis is going to be on the edge of the graph. So I'm going to basically just use the edges. Now, if I do that, that may restrict what I can see of these, but that's okay. Because in reality, when we do this problem in Chapter 3, this is going to say x is equal to or greater than 0 and y is equal to or greater than 0, which is what's going to make us do quadrant 1. So I've already taken care of that, by the way, that I have those. So I've drawn the lines. This is actually the line, remember I told you, x equals 0. And this is actually the line, y equals 0. So I have graphed those two already, just by the way that I labeled my graph. So now I need to look and see what my lines look like. So on that first one, and my calculator's died. On my first one, I've got 2x minus 5y equals 10. And if I put that in the calculator, that's going to be parentheses, start with the 10, then subtract 2x from both sides, close your parentheses, and then you're going to divide by the number in front of y, so that's negative 5. And while I'm sitting here, since I don't want to have to come back and do it again later, I'm also going to put in the other equation. So that's going to be parentheses 8 subtract x, close the parentheses, and then I'm going to divide that by positive 2. because that's the number in front of Y. And since I'm only looking at x equals 0 and y equals 0, I'm going to set my window up to go from 0 to 10 in both directions. So I'll put my minimum x value at 0 and my minimum y value at equal to 0, so that all I'll see is the first quadrant on this one, because that's where I'm interested in being able to work this problem,
Put the y min to 0.
as 0. Both of your mins need to be 0.
Can you go back to the y equals?
Sure.
Okay, thank you.
Okay? So now that we've entered our equations, we've set up the window, then all we need to do is graph and see what we see. So if I'm only going to look in the first quadrant, because that's the part that I'm interested in,
Am I only supposed to have the 2 equations in there? Or do I
yeah,
got
but you need to turn that plot off.
to turn the plot off?
That, push your enter key to turn that off. Because it's down. That's okay, just bring it down. Now just hit graph. Choose your hot line?
No.
No? Okay, let me see your equation again. You left out your division sign in your second.
Which one we had?
This one. You didn't put your divided by. You just put the 2. So if you hit graph, it should work.
Why is it blinking like that? Somebody too blinking?
That's because I inserted something in front of it.
Just enter it?
Yeah, just hit graph, it'll be okay.
Can you put it back to the windows?
All we did was we used the Zoom standard window and we just changed the X minimum and the Y minimum to 0. Not working? Let's see.
That's registered the Zoom standard.
You got it stopped. Okay, that's right. Change that to 0. And now hit graph.
You have both your equations. Here you can select this as a 0.
You have a cursor short?
So we can do
No, but I don't know what you're talking about. It's hard to find another way. If I know what that's easier.
I don't know why it's not graphing the
Here,
second
you
one.
just take, if you want to find y intercept.
Just graph the, right?
Yeah, you've been doing the others.
Yeah.
X intercept.
I have
So
no
the
idea.
Y, 0.
If you want to use this one, I have one on
Two
the
X, 0.
They should get
Two
X plus 0.
Okay. What you need to do is go ahead and get a regular, yeah, because there's obviously, apparently there's a glitch in the software.
Okay.
So that's a problem. Okay. Now,
That's all I do.
on the graph, we can still find the y-intercept of the 1, because we do see the 1 y-intercept. You can almost tell what it is. If you look, it's like 1, 2, 3, 4. But if you want to be sure, you go to second, trace, choose value, and say let x be 0 and show me what y is. And it says that y is -2. Well, that's because it's looking at the other line. The other line does have an intercept at -2. So you've got to be careful. You're looking for this line. This line has a negative slope. That line isn't going to have one. So go ahead and just use your cursor, and there it shows it to you on the screen which one it's actually giving you. So that one is 0, 4. So we go from the origin up 1, 2, 3, 4. Now I'm going to tell you in advance, we're going to have a problem doing the x-intercepts. I'm going to go second trace to the calc menu, and I'm going to ask it to show me the zeros. And if I want to see the zeros, I have to be able to tell which line I'm on. So right now I'm on this one. So if I get to the left of that, let me make that go back to where it was. So what I'm going to have to do is I'm going to have to trace until I actually can see what line I'm on. And it looks to me like I'm on the right line, because if I keep tracing, I finally see it pop up there. But I can't get to the left of that x-intercept. And on the other line, I'm going to be able to get to the left of it, but I can't move to the right of it. Because I've blocked myself off at the bottom of this graph. So the calculator will help you, but remember what I told you. That's why I wanted to do this one with you. Your calculator has to be able to see everything. It's not going to help you find your y-intercepts when it can't see the y-intercepts. The thing it can help me with, though, is it can help me find the intersection point.
Can you just move the, like, left round, right round past the X and Y?
You actually can. I'm going to show you how to do that. But let's start by finding the intersection point. Yes?
It's
Fine.
not letting me graph them.
Oh, you used a subtraction, that's the negative. Okay, so we're going to go ahead and find the intersection point, because it can see the intersection point. If you notice here, you can see that on the screen, so it can find that. So second, trace, down to number 5, enter, enter, enter. And it says the intersection point is 6.666666667. And the y value is 0.6666667. Now, if you know anything about your fractions, those actually are fractions. The first one is 6 2/3, and the second one is 2/3. But be aware, it's going to give you that kind of number sometimes. Now, if you really would like to know what they are in fractions, you go back to your home screen and ask it to show you x as a fraction. And it tells you it's 20 over 3. So if you do 20 divided by 3, that's the 6.66667. If you take 20 over 3, and then subtract the 6 and ask it to show you that answer, it'll turn the rest of it into a fraction. So that's 6 2/3. But the best thing to do, is, since we're trying to graph it on your calculator, is to realize that 6.666 and it's between 6.6 and 6.7. So we're going to go out here, get this up here where you can see it. We're going to scale this axis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6.67 is right about there. And then you have to go up, since this is 1, you're going to go up about 2/3 of the way. So this is the 0.6, this is 7. You go out to about 6.6 or 6.7, and then you go up, since that's 1, you're going to go up to about there. So there's your intersection point. Your intersection point is 6.67 and 0.67. You don't have to use the fractions. You can use decimals. Now what I know about this right now is that my first line is going to go through that point. So I can draw that line. So this is actually the line. You'll have to look on your calculator to see which one it is. Well, apparently I'll have to restart the calculator. Okay. So if I look on my graph, I need to know which line that is, so I'm going to hit my trace button, make sure which one I'm on. Okay, so that's the one that has 8 minus x divided by 2, so that would be the line that looks like this. But now I've kind of hit a roadblock, because I don't know how to go about drawing this other line because I've only got one point. So this is what you have to do. Remember, you have to be able to see both your x-intercepts and be able to get to the left and right of them. We're going to go back to the window, and we need to see further down. What would I adjust to be able to see below the x-axis? What do I need to change? The y minimum? What do I need to change it to? What do you think?
-5.
Well, you can go -10, -5, -1 or 2 even. Let's try -2.
Want to do the y exponent also?
No, because we're still going to stay in this first quadrant. You'll see in Chapter 3 why I'm staying in the first quadrant. This is just some graphing skills that I think will help you. Okay, now I can see both my x-intercepts, right? So I should be able to go second, trace, choose the 0, move a little bit to the left of that one, hit enter.
Which one are we doing, the x-intercept, the value?
The value. Then move a little bit to the right of that one and hit enter. And it says that is 50.
Do we not include the other y-intercept for the second graph?
We can, at this point we can see it. So here's 50. And that means that this line this is the other line, so that's 2x minus 5y equals 10. And then I need to find the other x-intercept. So I'll go second, trace, choose 0, and I need to jump to the other line. Get a little bit to the left of it,
Which line are you on?
the one that's going down.
Okay, minus X.
The 8 minus x divided by 2.
Second trace, and what are you looking for?
You're 0. And so that one's 8, 0. Now, if you really still want the other x-intercept, you can go back, second trace, choose value, and say, where is x equal to 0? And it says, well, for this line, it's where it's at -2. And if you look here, that kind of makes sense, because if I continued that on down, that looks like -1, -2. Okay? Now, there wasn't a particular reason that I set these axes up the way that I did, other than to make sure you understood that if the window that you're on doesn't actually let you get to the left and the right of your x-intercept, you're not going to be able to use your calculator to find it. So you need to understand how to adjust your window. So on your window, remember X-min. I'm going to draw you a little picture here. This is your calculator screen. This is X-min. This is X-max. This is Y-min. This is Y-max. So if you need to move your graphing window up and down, you either, if you're trying to move it up so you can see underneath something or see further down, you have to make Y-min go down further, which means it has to be more negative. If you wanted to, if you can't see the top of your graph, you're going to have to raise the ceiling. That's Y-max. If you can't see something you need to see that's because it's further to the left, then you need to adjust Y-min more negative. I'm sorry, X-min more negative. And if you need to see something further to the right, then you need to adjust X-max. Let's see if you understand. Here's my calculator screen. This is not this problem. This is just a situation you might run into. Here's your calculator screen. You've got a graph going this way and a graph going that way. And you need to see where those two lines cross. Can you see it on that screen? What do you have to fix to be able to see your intersection point?
A little higher on your X max.
That's right. You need to move X max higher. That number needs to go up. Okay? If your calculator screen looks like this, you're trying to find your intersection points. What do you have to adjust?
Why map?
Okay, because it's got to go up.
Might have to adjust the other one too, just to come out.
That's right. You might have to adjust this one too, depending on how long it takes to actually see them cross. So you might have to adjust X-max also.
Can you just do zoom out? That's why I usually do zoom out.
You can do zoom out, but the bad thing